the compiler sees it, each time it will replace pi with this value here, with this value. So we did take advantage of the pi, right? The constant macro here. You look at the next line because we are going to use the same value again. So it's just better using notations. That is the constant macro approach. And the constant macro, it is implemented at the compiling stage. When the source file it is compiled, the constant macro it is handled by the compiler. It is handled by the compiler. Okay. And finally, as I'm saying, everything's done in the computer, but we really don't know. So certainly we needed to consider put something out as output. And so these are the messages you will see on the screen when it's all done. So this is the so-called top-down design approach. It is a very intuitive approach. You do one thing at a time, and then you move forward. Certainly, when you want to implement a task using the C language, you are going to follow the C syntax. They are preprocessed directives, and they're the main function. Then you declare the variable, and then you carry out those tasks. Okay, follow the C language. Okay, C syntax, the arrangement of C language closely. This is the assignment operator. You cannot swap left and right because that really won't make sense. Okay, assignment operator always works in the fashion like from right to left, And also remember the asterisk here, it's the multiplication operator. And in this case, there's only multiplication involved. And also we have addition, subtraction, division, those are operators. So this is a very simple C program. And well, I guess this is our not the first time, actually at least third time or even fourth time to talk about the general structure of C program, how we create a source file. Let's move on. The next part, it is a brief discussion of library functions. And you may wonder, why do we need to use those library functions? First of all, it should be clear, we already used some of those library functions, like a printf, scanf. These are the library functions. I'm saying printf, scanf. Those are used to carry out some basic tasks on import and output. And otherwise, remember we said C language, it is complicated. If you really want to do some actual programming, really in some way, if you are communicating directly with the machine, you may only get one dot as output. And then this is really not very helpful, right? So mostly those basic import output tasks, they are pre-written and they are pre-compiled. They already exist. You don't have to repeat those tasks. When you need to use them, just call them. You call functions. So basically, the library functions, basically they are designed to be used again and again, using program fragments that have already been written and tested. They are very well written and very well tested. Okay, and especially for those pre-written codes, okay, they are being written and tested and they've been compiled. And for some common tasks, okay, those functions together, they form some standard libraries. And one particular standard library, it is the standard import output. And let's take a quick look again. Okay, in the beginning part, preprocessor directive part, when you have include hashtag, the pound sign, include angle brackets, stdio.h, you are assigning to include, tell the compiler to include standard import output library functions. In particular, we need a printf and a scanf. Okay, library functions, and the standard import output functions. And also there are other functions. There are other functions like to calculate the square root. In no way the machine, the central processing unit, knows how to calculate the square root, and the programmers will tell the computer, the central processing unit, to handle square root. So usually square root is a pre-written function. It is a pre-written function. By the way, the square root, I believe it is included in another library function. Another library function, it is called as math.h. Square root program, figure 3.7. Okay, besides include standard import and output, we also include math.h. Math.h, it is the library with common math functions like square root, okay. Square root SQRT, it is not part of the C language, but anyway, it is developed in a library function. There are multiple libraries, and so far we haven't seen the standard input-output library, and we have math library. Okay, the library for math functions. This is a continuation for the square root function, and some other functions in the math library, like the absolute value of the function. You can tell that's the absolute value. CO function, it's a little different. And we'll talk about the CO function later. And also we have the logarithm, the sine, and the square root. Okay, square root. And these are the functions written and compiled into the math.h, math library functions, two libraries, the standard import and output, and math. Again, top-down design. Top-down design, it is a problem-solving method. And first, you break a program into some small parts or subprogram, and then solve the subprogram to derive the solution for the original problem. Okay. And then function part. Basically, each subprogram it is considered as a function, and the thing is, how can we write a function by ourselves? So the so-called function prototype, function syntax to write a function. Okay. First of all, you need to declare the type of the function. Then you need to create a name for the function. Okay. You need to create a name for function, and then followed by a pair of parentheses. Inside the parentheses, there's a keyword void, because this is the syntax for function without inputs. Arguments, consider the arguments are just for inputs, really. Okay. And then with pair of bracelets, and then inside you declare variables, and then you make some manipulations. Usually there are assignments involved, assignment operators involved. Okay, so this is in general how you write a function. And for now, I would say if you have any confusion simply reading the arrangement on the screen, think about the main function. Main function is a function. Okay, so for the main function, the function type simply it is integer type. So we have int. Fname, the function name is simply called as main. And for the void part, we just usually just for the main function, we just put a void there. Then it has a pair of bracelets. That's the body of the function. Then we declare variables. And then we have assignment operators, assignments, and then we have printf, scanf, those things. So it doesn't match. It doesn't match the kind of, well, it doesn't match the main function we used several times already. Let's see the definition of a function. The syntax, how to define a function. Okay. And then the placement of functions in a program, I guess I'm going to skip this part of discussion for the moment, and we'll see how we place a function. Well, placement of a function in a program, let's say I'm going to say, like, remember the printf, scanf? Well, whenever it is needed, you place the function where it needs to be put in a simple way. Okay. And for the main function, there's not a lot to talk about. To talk about it, and because each program has to have a main function, and besides, it has only to have one main function. But anyway, when you write functions other than main, and basically these are the advantages. There are more, but anyway, these are the advantages you will want to know. Or really, these are the reasons why we consider functions or function subprograms. First, it is for the purpose of procedural abstraction. Procedural abstraction, it is a programming technique in which a main function consists of function calls, and each function is implemented separately. And for now, because we are really only having the main function, so let's move back to the various first source file we talked about here. Okay, a main function, a function, this is a program, even though it only has a main function. And then inside the program, there are multiple calls for function. Printf, scanf, these are function calls. These are function calls. And also there are assignments there, okay? Assignment statements there. So I say it makes sense. Well, it doesn't make, otherwise, if you don't use the printf, scanf, you'll say you want to start from scratch. Really, you need to do a lot of work. There are a lot of codes involved, simply just to display the message under radius on the screen. And certainly there are a lot of more work. You want to take the import from the keyboard. But anyway, with the function call, it does make the program a lot easier to read and to follow, right? And another reason, another advantage of using functions, you see printf. And the printf again and again, it lets us to reuse those functions again, recycle the code, because they are doing the same task. They are just going to show some messages on the screen, display the messages, different messages. So the same function can be reused again and again. Program efficiency. Okay, program efficiency. So these are the purpose to write functions, to use functions. And also, this is in general how you declare a function. Use the main as a function there, okay. Advantages of using functions. How about before we continue, let's take a break. Thank you for watching.